So what we're going to show in this part of the demos is how to use generic tools. So the generic tools are a set of our suite of tools to allow the user to execute any of their model. And the idea is to create them flexible enough to allow different types of model to be executed inside CyberWater. And the idea is that the user have to use the least amount of code possible to make the process very smooth. And this is where we need the biggest amount of feedback in order to for us to like work hard on make this as flexible as possible, so the users can just add even different types of models that models that we haven't taken into account to see how effective our abstraction of the models are. So for this, we thought about making the exact same execution of the French Creek that we just showed. But instead of using the Vic agent, we're going to use the generic tools. So I have here prepared. So these are all the forcings and the pre-processing that we have prepared for the Vic. But in this case, just to say it, we're going to use the generic tools. Generic tools are 5 components, main components. The first one is the main generator. And the main generator is in charge of setting up the working directory where the execution is going to be performed, receiving the forcing data that the model requires for execution. And also, if the model has any configuration file or any main file where the configuration starts, like a main file, then the user should add it here. Okay, so our working directory is here. If the user wants to browse its own computer to find it, the user can just click here in this icon, and you would just select the folder where you want to perform the execution. So it'll be here. Perfect. The second one is this global file. We call the global parameter file as GPF. And again, the user can just go and select their specific global file. Okay. And the rest is just a matter of connecting the forcings. And this is the only tricky part, because the user needs to understand where the location of each one of the forcings are inside the forcing files of the model. So we know that the model in this global file, the order that Vic is expecting the forcings to be is first maximum temperature. That was going to be the first data set. We're going to activate the other 3. The second data set is going to be the minimum temperature. The third one is going to be the precipitation. And the last one is going to be the wind. Yeah, everything else from now on is just following the instructions of the generic tools, which are very simple. So the next step is going to be the area parameter generator. And this one is in charge of setting up the parameter files of the simulation. We only need to include the parameter files that this Vic simulation requires. And the only connection that this needs is the working directory. So this is the working directory path. We connect it here. And everything else is just a matter of selecting the right parameter file. So fractions, and then here is going to be snow bands. There are a total of 5 parameter files for this version of Vic. So those are the ones that we're adding in the vegetation library and the vegetation parameter file. That's it. And the next part is the forcing file generator. What this does is it transforms the forcings that we have put into the main agent to a format that the model understands. So far, this model is distributing the information of the forcings into individual cells. And this way, we're able to run Vic, DHSBM, our routing model that we have, and also the CASA CMP model. So this one requires us to give the working directory as well, where the files are going to be created. And this dataset class are going to be the datasets that contain the information of the forcings. I think that's all we need. Yeah, that's all we need. And the last one, oh, that's it. We don't need anything else because first we want to show an example without initial state file, and later we want to show an example with initial state file. The last part is the run module agent. And this one does the actual execution of the model. And after it executes the model, what it does is we have to give it instructions to read the results properly. So we're going to give it first, these output names are just labels. These are the labels of how the variables are going to be named. So we want to name the first one surface runoff and base flow, which are the variables that we just show in the previous example. And the file position is, so for the generic tools, the user has to have some knowledge of their own model, right? So here we need to know which column number or column index these variables that we want to plot are located. So these two are located, the runoff is in column number 5 and the base flow is located in column number 6. So those are the two numbers we're gonna add. And later we need to know the name of the result files. So name of the result files, we can ask either a single result file or results file that are distributed in different cells in a grid. So in this case, they're distributed in a grid, and we just have to add the prefix. If they're a single file, then we have to give the complete path of the file or the relative to the working directory. That's the path we need to give. And then the other two things we are missing is the argument. So this is the argument of the execution. As the user has the executable file, it needs to give or know the pattern of the arguments for the execution. And this is just the path of where the executable is located. The reason why this doesn't have a browsing button is because sometimes the execution requires parameters that go previous to the name of the executable, which is the case for Java. So we have left this without that constraint, so the user can execute different types of models. And here, this guy is requests the ready, like a list of the ready flags for the previous one. So we organize the execution of this one before, after these two. And it also requires the working directory, and it also requires the information of the data sets that are coming, just so for you to have an idea of the format of the outputs that are going to be created. Wait, I think I have to connect this. Yeah. Okay. I think that's all we have to add for this one. And we only need to add our MSM show chart. And one of them is going to show, we can also control the outputs. So because we know we want two outputs, and we have to activate the second output port. And then we connect them. Let's just say, I think the first one is runoff. The second one is base flow. So let's call this surface runoff. And this one is going to be the base flow. And because this guy knows the name, but he doesn't know the units. So we have to give the units in this case, units and units. I think that's all we need, and just execute this. Okay, it's taking some time, and I think it's probably because we have all these things open. Just close this, and let's see what the error is. It's probably just the numbers. Oh, the state. Okay. Okay. Sorry, I have to update this state file. And after I update the state file, I'll execute this again. Okay. Okay, need to change this to params. So I forgot to add this part. This part is the name of the parameter file that it has to be created inside, and this one has to be the same name that you add in the global parameter file. Let's see what else. Okay, yeah, it's executing. Okay. Um, so these are the results, and for some reason they're not exactly the same as we had before. And okay, let's make the execution with the initial state file and let's compare them. So if a user wants to add the initial state file in the generic tools, if there is a module called initial state file generator. In this initial state file, it works in the same way as the area-wise parameter generator. You can just go ahead and add the state file, which is the initial state file, and the initial state folder name, I think is going to be state. We confirm. I think that's correct. Let me check before. No, I think it's just state like this. Okay. And it needs to connect the working directory, like the area-wise parameter generator, and it also the output is already flagged, just the area-wise parameter generator. But here, what we need to do is we need to make sure I'm using the right global parameter file, so we don't have issues. Just check this. Yes. Okay. This one seems to be fine. Let's execute this. Okay, so this one has a different parameters. So parameters. There's an error with the state file. I just tested this. Okay. Let me see.
You think we can somehow move on, Daniel, or?
Give me 2 seconds. Let me try with a different initial state file. And if it doesn't work, then we can just move ahead with the next module. Let me see. The next demo, sorry. Let me see. Let me try with this one. Okay, I think. Okay, I have them previously executed here. Maybe we can do that. Let me see. So this is the example without the okay, this is the example without the initial state file, and these are the results we obtain for the execution of the VIC. They're the same, and this is the execution with the initial state file. And the reason, yeah, well, the reason why this is different is because when you make an execution inside CyberWater, the values of the results are stored in cache. So you can compare the results of the executions you have done previously. And here you can really see the difference between an execution with the initial state file and without the initial state file. Have to check what changed between the files. Probably I changed some of the parameters, but these are the results we're expecting. And I don't know if there's any questions.